So we have a few more 7.3 exercises that are similar to homework problems to work through. And here's exercise 12. If sine t is 3/7 and t is in quadrant 2, find cosine t and tangent t, no calculators. You don't need to draw a picture always for these, but I just want to draw a picture here of the unit circle situation where what we're saying is, so t is some angle in quadrant 2. So remember how t can represent an angle measure. And on the unit circle, since we know sine t is 3/7, we know some information about this point on the unit circle, right? We know the y-coordinate is 3/7. The x-coordinate, what goes in here, would be cosine t. And that's what we're trying to, one of the things we're trying to find here. We're actually going to do this problem without ever actually determining the angle t. We're just going to go right from sine t to cosine t and tangent t. So that may seem a little bit weird that we're not going to find the angle. With a calculator, you could find the angle. We just did that unit circle activity. That only involves special angles here. Here, we don't have one of our special angles involved because we're not getting one of those famous values of sine and cosine. So the special angles in the unit circle diagram don't help us at all for this problem. All right, so what we're going to do is we will solve this problem two different ways. I think it's really helpful to see these two different approaches, and you may choose either method. You don't have to know both ways. So if one way makes more sense to you than the other, stick with the way that makes more sense. And so here's method 1 for solving this problem. I'm going to use the Pythagorean identity. So the Pythagorean identity is that the sine squared of an angle plus the cosine squared of an angle is equal to 1. Here I'll write it out with t. So sine squared t plus cosine squared t equals 1. It doesn't matter whether you write the sine or cosine term first, because we're just adding two quantities there. You can write it in either order. And we know the value of sine is 3/7. So I'm gonna plug in the value of sine t, 3/7. And remember, this notation stands for squaring that. Plus, I'm going to rewrite this as cosine t in parentheses squared, again what that shorthand means, equals 1. And see, now we can solve for cosine t. And the Pythagorean identity is really useful for this type of calculation, where if you know the sine, you can solve for cosine. If you know the cosine, you can solve for sine. So let's go ahead and do that now. We got 9/49 plus cosine t squared equals 1. So cosine t squared is 1 minus 9/49. Now that's going to be 49/49 minus 9/49. So I got 40/49 here, doing that fraction subtraction, is cosine t squared. So notice I isolate cosine squared. And now I can take square roots. And I'm just going to move over to the left a little bit here to use space more efficiently. So cosine t is equal to plus or minus the square root of 40 over 49. And now, the Pythagorean identity is always going to give us a plus or minus sign. So this formula in itself doesn't tell us whether to choose a plus or minus. But if we are given additional information about an angle, such as the fact that we're in quadrant 2, okay, then we know in quadrant 2 x-coordinates are negative. We know the cosine is negative. So for this problem, we know we have to use a minus sign. And then we get square root of 40 over square root of 49. And so cosine t is equal to, don't get too worried about simplifying square roots, but I hope you can see that denominator is just 7. The numerator, I have 4 times 10 inside that square root, so I can write it as 2 times the square root of 10. And there's my exact value for cosine t. Okay. Now we also want tan t. And so we're going to just come up over here. And my feeling is for the vast majority of times that you want other trig functions, if you know sine and cosine, just use the values you know. You don't have to go directly to tangent. So for instance here, tangent I know is sine t over cosine t. So I can just write 3/7 over negative 2 square root of 10 over 7. Okay. And then I just have a little division problem to work out. That's 3/7 times, that's going to be 7 over negative 2 square root of 10. 7's going to cancel. And I'm going to end up with, I can pull the minus sign out in front, negative 3 over 2 square root of 10. I'm happy if you leave your tangent answer that way. Remember that was our tangent, right? If you want to rationalize, can I squeeze that in down here? You can take that answer and multiply by square root of 10 over square root of 10, and you get negative 3 square root of 10 over 2 times 10 is 20. Either one is okay. You don't need to write that both ways. So we have cosine and we have tangent. Okay. Now that was method 1. Now we're going to do the same problem a different way, and we can compare the two. Method 2 is using a reference triangle, I call that. So since t is in quadrant 2, I mean it would have to be an angle greater than 90 degrees, right? T cannot be an angle in a right triangle. So we will use the reference angle for t. So I'm invoking the reference angle here, and I'm just going to write that as REF angle in this problem. So the sine of the reference angle is also going to be 3/7, right? We were told that the sine of our angle is 3/7. And The sine of the reference angle is always positive, so it would also be positive. 3/7. Same as sine t. I can draw a right triangle with the reference angle. So I can always draw a right triangle with a reference angle. And so here's my right angle. I'm going to call this the reference angle. And I can use SOHCAHTOA now. I'm using SOHCAHTOA to label the sides of this triangle. I want the sine to be opposite over hypotenuse. So here's my reference angle. Opposite is 3. Hypotenuse is 7. Now we got to solve for the adjacent side. So x squared plus 3 squared is 7 squared. We're using the Pythagorean theorem. X squared plus 9 is 49. X squared is 40. X is going to be the square root of 40. But here, x is the side of a triangle, so it's got to be positive. And that's also 2 square root of 10. In fact, there's a similarity between what we're doing now and what we just did, right? In fact, some people find the messiness of this a little nicer. So let's see, we can say thus cosine of the reference angle is adjacent over hypotenuse. If this side is 2 square root of 10, the cosine of the reference angle is 2 square root of 10 over 7. Okay. Now cosine t is going to be plus or minus cosine of the reference angle. So when you go back to the angle t, we got to decide whether to use the same value or the opposite value as the reference angle cosine. The reference angle cosine will always be positive. So we got to choose. And we know what to choose because we're in quadrant 2. Because we're in quadrant 2, we know to use minus the cosine of the reference angle. And so maybe I'll note here quadrant 2. It's only the quadrant that tells us to use that minus sign. And so there's my cosine of t. Cosine t is negative 2 squared. I mean, we kind of did the same calculation both ways. It was a little less messy this way, but we also had to juggle this idea of reference angle. Tangent t is also going to be plus or minus the tangent of the reference angle. That means plus or minus, I could use TOA in my diagram here. So that's 3 over 2 square root of 10, right? So I'm using the TOA of SOHCAHTOA here. And again, I need to choose. I can't have both. And again, because I'm in quadrant 2, I know tangent is negative in quadrant 2. And so here's my value for tangent, which you could also rationalize and write in that form. So that's the reference triangle way to do the problem, using a reference angle and a reference triangle. We're going to contrast that with our method 1 solution, which used the Pythagorean identity. There we just worked with t. In each case, we had to be very much aware of the quadrant that t was in, and the fact that the cosine of t would have to be negative since t is a quadrant 2 angle. Okay, so I'm just going to leave us at that, and we're going to do a little bit more of this in the next video.